If I change to Ban Roll-On deodorant, will my dreams come true?
I don't know, but mine will.
Ban, the long-lasting roll-on.
Tonight, our story begins not with a solution, but with a problem. A small, intimate, and universally frustrating problem. The mess of application. Before the modern age of elegant dispensers, the simple act of putting a liquid or a cream onto a specific part of your body or a specific spot on a piece of paper was an exercise in imprecision and waste. Imagine the daily ritual of personal grooming in the early 20th century. The product of choice was a thick, often waxy or greasy, deodorant cream scooped from a wide-mouthed glass jar. The process was a tactile nightmare. You would dip your fingers into the jar, scooping out a clumsy dollop of the substance. The cream would immediately coat your fingertips, getting under your nails. You would then attempt to rub this onto your skin, but the application was never even. It would be a thick, pasty, and often visible layer, prone to clumping and leaving a sticky residue. Too much product was always applied, which would then stain the inside of your clothing. After the application, your hands were a mess, requiring a thorough washing to remove the greasy film. The entire process was inefficient, unhygienic, and deeply unsatisfying. It was a moment of friction and clumsiness in the quiet routine of the morning. The alternative was a liquid, but this came with its own set of problems. Early liquid antiperspirants were often harsh chemical solutions, aqueous and thin. They were applied with a cotton ball or a small puff. You would saturate the cotton, which would immediately start to drip. You would then dab or wipe the liquid onto your skin. The cotton would absorb as much of the product as it applied, leading to immense waste. The application was a wet, messy affair, with the liquid running down your sides and the saturated cotton ball leaving a trail of drips on the floor or vanity. Control was impossible. You were either perfectly sparing and likely ineffective, or generous and left with a wet, dripping mess. This same problem existed in other parts of life. Think of the schoolchild with a pot of mucilage glue. It was a thick, viscous, brownish substance, often with a small brush attached to the lid. The brush would emerge from the pot, heavy and dripping with a stringy strand of glue. Applying it to a piece of paper was a guarantee of a lumpy, wet, and wrinkled mess. The brush would apply far too much glue, which would squeeze out from the edges when the second piece of paper was pressed down. The result was a sticky, uneven bond and glue-covered fingers. The world, in these small moments, was a place of imprecise and wasteful application. There was no clean line, no even film. There was only the jar, the pot, the puff, and the drip. The problem was a quiet, daily annoyance, waiting for a simple, elegant solution. It was the problem of how to get just the right amount of liquid from a container to a surface, without waste and without mess. The frustration with messy application was not an unrecognized problem. For decades, inventors and manufacturers tinkered with solutions, creating a series of precursors to the modern dispenser. These were the stopgap measures, the transitional objects that tried, with varying degrees of success, to bridge the gap between the clumsy pot and the clean, controlled application of the future. Each one was a small step forward, but each came with its own unique set of flaws. One of the earliest solutions was the powder and puff. Deodorant powders were common, offering a dry alternative to greasy creams. The applicator was a large, soft puff made of velour or lamb's wool. While it avoided the wet mess of liquids, it created a different kind of chaos. The puff would pick up a large, uncontrolled amount of powder. Applying it would send a fine, dusty cloud into the air, settling on clothing and furniture. Application was imprecise, a broad dusting over a general area, rather than a targeted application. Furthermore, the powder offered little in the way of antiperspirant properties. It primarily absorbed moisture and masked odor. It was a dry mess, but a mess nonetheless. For liquids, the dabber or dauber top was a significant innovation. This consisted of a bottle topped with a porous membrane, usually made of felt or a fine mesh screen, often spring-loaded. When you inverted the bottle and pressed the dabber against a surface, the spring would compress, allowing the liquid to saturate the felt pad. You could then dab the liquid onto your skin or paper. This was the technology of the bingo marker, and it was a notable improvement. It eliminated the need for a separate cotton ball and reduced dripping. However, it was still far from perfect. The felt pads would often become clogged with dried product, rendering them useless. They were prone to fraying and falling apart over time, and the application, while better, was still a series of wet, circular dabs rather than a smooth, continuous film. Another approach was the spray atomizer. This was a rubber bulb attached to a tube, which sat in a bottle of liquid. Squeezing the bulb would create a fine mist. This was a glamorous and popular method for applying perfumes and colognes, but for deodorants, it was inefficient. The spray was wide and undirected, with much of the product being wasted into the surrounding air rather than landing on the skin. It created a cold, startling cloud, and the propellants were often harsh. A more direct form of spray, the squeeze bottle, also emerged, a simple plastic bottle that, when squeezed, would emit a jet or spray of liquid. This gave more control than the atomizer, but was still imprecise and prone to applying too much product in a single wet blast. Each of these inventions was a sincere attempt to solve the problem of the spill, the smudge, and the drip. They were the necessary evolutionary steps that highlighted the remaining challenges. The world was still waiting for a system that was sealed, clean, direct, and could deliver not a dab, not a spray, not a puff, but a single, silent, and unbroken film. The solution to the messy problem of applying deodorant did not come from the world of cosmetics or toiletries. It did not come from a chemist in a lab or a designer in a packaging company. It came, as so many great innovations do, from a completely unrelated field. The spark of inspiration came from the world of writing, from a humble, revolutionary object that had already solved the exact same problem, but on a microscopic scale. The invention of the roll-on was made possible by the invention of the ballpoint pen. The ballpoint pen was conceived and perfected by a Hungarian newspaper editor named László Bíró in the late 1930s. Bíró was frustrated with his fountain pen. It was a messy, unreliable instrument. The ink was slow to dry, prone to smudging, and the pen itself would often leak. He noticed that the ink used in newspaper printing presses was the opposite. It was thick, viscous, and dried almost instantly. The problem was that this thick ink would not flow through the fine nib of a fountain pen. He needed a new kind of delivery system, one that could apply a thick, sticky ink in a clean, consistent line. His genius was to place a tiny, free-rotating metal ball bearing in a socket at the tip of the pen. This ball had two functions. First, it acted as a cap, sealing the ink reservoir from the air and preventing the thick ink from drying out. Second, it acted as a continuous applicator. As the pen was moved across paper, the ball would rotate. The back of the ball would pick up a thin film of the thick ink from the reservoir inside the pen. As it rotated, it would carry this film of ink to the front and deposit it onto the paper. The fit of the ball in its socket was the key. It had to be loose enough to rotate freely, but tight enough to prevent the ink from leaking out around it. This was a perfect, self-regulating system. The pen only delivered ink when the ball was rolling, and it delivered a perfectly consistent, thin line. It worked at any angle, it didn't leak, and the ink dried almost instantly. It was a complete solution to the problems of the fountain pen. Bíró had, without realizing it, created a universal principle for fluid application. He had proven that a rolling sphere, held in a precisely engineered socket, was the most efficient and cleanest possible way to transfer a liquid from a reservoir to a surface. The quiet, almost invisible rotation of that tiny steel ball was a revolution in controlled flow, and it held the secret that would, a decade later, be scaled up to solve a completely different but fundamentally identical problem. The world of writing had unknowingly provided the answer for the world of cosmetics. The tiny ball that drew a clean line was about to become the big ball that stopped the spill. The conceptual leap from the tip of a ballpoint pen to a new kind of deodorant dispenser did not happen in a large corporate research and development lab. It happened in the mind of one observant and resourceful woman, Helen Barnett Diserens. In the late 1940s, Diserens was working as an associate at a small company called Mum, which was a subsidiary of Bristol-Myers. The Mum brand was a pioneer in the deodorant market, having created one of the first commercially successful deodorant creams in the late 19th century. For over 50 years, their product had been sold in a familiar jar applied with the fingers. Diserens, like millions of other women, was intimately familiar with the messy, frustrating ritual of using the product she helped to sell. The story of the invention is a perfect example of associative thinking, of connecting two seemingly unrelated ideas to create something entirely new. Diserens had been exposed to the new marvel of the ballpoint pen, which was just beginning to become popular in the post-war years. She understood its mechanism, the clean, reliable line it produced, and the way the tiny rolling ball controlled the flow of a thick, syrupy ink. At the same time, she was confronted daily with the problem of the deodorant jar. The problem, as she saw it, was not the deodorant formula itself, but the delivery system, the clumsy, unhygienic, and wasteful method of application. The moment of epiphany, the quiet spark that changed an entire industry, was a simple but brilliant question. What if the ball was bigger? What if, instead of a tiny metal sphere delivering ink to paper, a larger sphere could deliver deodorant to skin? She envisioned a device that worked on the exact same principle as the pen. A plastic or glass ball, held in a socket at the top of a bottle, would seal the liquid deodorant inside. When the ball was rolled against the skin, it would rotate. The part of the ball inside the bottle would pick up a thin, even film of the deodorant liquid. As it rolled, it would transfer this perfectly measured film onto the skin, silently and cleanly. It was an idea of stunning elegance and simplicity. It would solve every single problem of the existing methods in one go. It would be hygienic, as the fingers would never need to touch the product. It would be economical, applying a thin, controlled layer with no waste or dripping. It would be clean, with no messy residue on the hands. And the sealed system would keep the product from drying out or becoming contaminated. Diserens took her idea to her superiors at Bristol-Myers. The concept was so compelling and so logical that they immediately saw its potential. They gave her the green light to develop a prototype. The quiet, personal frustration of one woman, combined with her observation of an unrelated technology, was about to blossom into a product that would completely redefine a category and become a staple of daily life for billions of people around the world. The journey from a simple, powerful idea to a working, mass-produced object had begun. Helen Diserens' idea was brilliant in its simplicity, but translating that idea into a functional, reliable, mass-producible object was a formidable engineering challenge. It was not as simple as just scaling up a ballpoint pen. The dynamics of a large sphere dispensing a thin liquid onto human skin were vastly different from a tiny sphere dispensing a thick ink onto paper. The entire team of designers and engineers at Bristol-Myers was now faced with the quiet, intricate challenge of the sphere. The first problem was the ball itself. What material should it be made of? Early ballpoint pens used a steel ball, but a steel ball for a deodorant applicator would be cold, heavy, and prone to corrosion from the chemicals in the antiperspirant liquid. The team first turned to glass. A ground and polished glass marble was an elegant solution. It was smooth, chemically inert, and had a pleasant, cool feel on the skin. The earliest prototypes, and indeed the first commercially produced roll-ons, used a glass ball. However, glass was also fragile and relatively expensive to manufacture with the required precision. The future would lie in plastic. The development of new, hard, and smooth plastics like polypropylene allowed for the creation of lightweight, unbreakable, and perfectly spherical balls through a process called injection molding. The second and far more complex challenge was the housing that held the ball, an assembly known as the fitment. This was the heart of the invention, and its design was a matter of microscopic precision. The clearance, or the space between the ball and the wall of its socket, was the single most critical factor. If the clearance was too tight, the ball would be pinched. It would not rotate freely, and the liquid would be unable to flow around it to coat its surface. The dispenser would be useless. If the clearance was too loose, the opposite disaster would occur. The dispenser would leak. A constant messy dribble of liquid would escape from the gap, defeating the entire purpose of the invention. The engineers had to find the perfect microscopic gap, a space of just a few thousandths of an inch that would allow the ball to spin with silent, frictionless ease, while still forming a tight enough seal to prevent leakage when held upside down. Furthermore, the inside of the socket needed tiny, almost invisible channels or ribs molded into its surface. These channels were designed to guide the liquid from the bottle up and around the sides of the ball, ensuring that the entire rotating surface was consistently coated with the product. The design of the fitment went through countless iterations, a quiet, painstaking process of trial and error, of creating a mold, producing a part, testing it, and then making minuscule adjustments. It was a masterpiece of fluid dynamics and mechanical engineering on a small, domestic scale, a puzzle of plastics and tolerances that had to be solved before the ball could finally and reliably stop the spill The successful invention of the roll-on dispenser was not just a story of mechanical engineering. It was equally a story of chemistry. The team at Bristol-Myers quickly discovered that the elegant plastic ball and its precisely engineered fitment could not, by itself, solve the problem. The existing deodorant formulas were completely incompatible with the new device. A parallel and equally important challenge had begun: the quiet reinvention of the liquid itself. The old deodorant formulas were simply not designed to be dispensed by a rolling ball. The thick, opaque creams that were sold in jars were far too viscous. They would not flow. They would simply sit at the bottom of the bottle, never making their way up to coat the ball. The dispenser would roll on dry and useless. The watery, thin liquid antiperspirants, on the other hand, had the opposite problem. They were too thin, with a viscosity close to water. Even with the most perfectly engineered fitment, this thin liquid would find the microscopic gap between the ball and the socket and leak out, especially with changes in temperature or air pressure. The mechanical solution required a chemical solution. A brand new type of formula had to be created from scratch. The chemists were tasked with creating a liquid with a very specific and delicate set of properties. It needed to be thin enough to flow easily from the bottle and around the ball with a gentle tip of the hand, ensuring the ball was always coated and ready for application. However, it also needed to be just viscous enough, just thick enough, to stay put when the bottle was stationary. It had to cling to the ball and not drip or leak through the fitment. This property is known as thixotropy, where a liquid's viscosity changes under stress. The ideal roll-on liquid is a gel-like substance that thins out when it is agitated by the rolling ball and then thickens again when at rest. Furthermore, the new formula had to be a stable emulsion. Deodorants are complex mixtures of active ingredients like aluminum salts, fragrances, and moisturizers, often suspended in a lotion-like base of oil and water. The chemists had to ensure that these components would not separate over time in the bottle, which would clog the dispenser or change the product's effectiveness. And finally, the liquid had to dry quickly on the skin, leaving a clear, non-sticky, invisible film. The user experience was paramount. The sensation had to be clean, smooth, and comfortable. This led to the development of the iconic, slightly milky, translucent lotions that we now associate with roll-on products. It was a quiet, invisible revolution in a bottle. The perfect marriage of mechanics and chemistry, the ball and the liquid, had to be achieved. Only then could the system work in the silent, flawless harmony that its inventor had first envisioned. After years of quiet, intensive development, after countless iterations of the plastic fitment and dozens of reformulations of the liquid, the team at Bristol-Myers finally had a product. It was a complete, elegant, and perfectly functioning system. The mechanical challenge of the sphere had been solved, and the chemical challenge of the liquid had been met. Now came the final, and perhaps greatest, challenge, introducing this strange new object to the world. In 1952, the first ever roll-on deodorant was launched onto the American market. It was given a short, memorable, and declarative name, Ban. The design of the Ban bottle itself was a piece of minor marketing genius. It was a heavy, substantial glass bottle, which gave it a feeling of quality and permanence, like a piece of cosmetic equipment, rather than a disposable item. The shape was a distinctive tapered form that was easy to grip. At the top was the revolutionary applicator, a white plastic fitment holding the precious marble-sized ball, protected by a simple screw-on cap. The name Ban was printed in a bold, clean font. The entire package was designed to look modern, hygienic, and scientifically advanced. It looked like nothing else in the deodorant aisle. The marketing campaign had a unique task. It didn't just have to sell a product. It had to teach consumers a new behavior. The concept of rolling on a deodorant was completely alien. Early advertisements and in-store demonstrations focused on explaining the mechanism, often with diagrams showing how the marble top worked. They emphasized the three key benefits that Helen Diserens had first envisioned. It was clean, with no mess on the hands. It was economical, with no waste. And it was easy to use. The tagline, "It rolls on," became a simple, powerful explanation of this new technology. The consumer reaction was not instantaneous, but it was profound. For those who had spent years dealing with messy creams and dripping liquids, the experience of using Ban was a revelation. The cool, smooth glide of the ball on the skin, the silent and controlled application, the quick drying and non-sticky feel, it was a quantum leap in user experience. It transformed the daily chore of applying deodorant into a quick, clean, and almost pleasurable moment. The product was a runaway success. It was more expensive than the old creams and powders, but the public was willing to pay a premium for the immense convenience and elegance it offered. Ban Roll-On became one of the most successful product launches of the decade, and it completely reshaped the landscape of the deodorant market. The quiet epiphany of one woman, brought to life through years of meticulous engineering and chemistry, had finally reached the public. The little ball in the bottle was about to become a global phenomenon. The ultimate success of the roll-on dispenser lies not just in its mechanical ingenuity, but in the unique and deeply satisfying sensory experience it provides. It is a technology that engages the sense of touch in a way that is clean, precise, and profoundly comforting. The sensation of the roll is the quiet, psychological contract that the dispenser makes with its user, a promise of order, control, and cleanliness. The experience begins the moment you touch the ball to your skin. Unlike the jarring, cold blast of an aerosol spray or the messy, warm stickiness of a finger-applied cream, the touch of the roll-on ball is cool, smooth, and solid. It is a focused point of contact, a gentle pressure that is both calming and precise. The coolness of the glass or plastic sphere is inherently pleasant, a refreshing sensation that signals the beginning of a clean, hygienic process. There is no shock, no mess, just the quiet, deliberate placement of a perfect sphere. Then the movement begins. As you glide the dispenser, the ball begins to rotate, and this is where the true magic lies. The rotation is almost perfectly silent and frictionless. It is a smooth, continuous, and effortless glide. It is the feeling of a polished stone skipping over the surface of a still lake. This silent, easy motion is the physical manifestation of the product's efficiency. It feels intelligent, as if the device knows exactly what it is doing. There is no scraping, no stickiness, no resistance. It is the opposite of the clumsy, frustrating rubbing motion required for creams. The roll-on moves with a confident geometric certainty. As the ball rolls, it delivers its payload, a perfectly thin, perfectly even, and perfectly controlled film of liquid. You can feel the cool, moist track it leaves behind, a sensation that is both refreshing and precise. The layer is so thin that it is almost intangible, and it dries in a matter of seconds. There is no clumping, no visible residue, no sticky feeling. It is the application of an invisible, protective layer. The process is complete almost before you have had time to think about it. The result is a feeling of clean, effortless efficacy. The roll-on dispenser transformed the application of a product from a messy, tactile chore into a clean, smooth, and almost meditative ritual. It is the quiet, daily affirmation that a complex problem can have a simple, elegant, and deeply satisfying solution. The initial success of Ban Roll-On, with its glass ball and glass bottle, proved the viability of the concept. But for the rolling ball to truly conquer the world, it needed to shed its heavy, fragile, and expensive origins. The next great leap for the roll-on dispenser was not a change in its fundamental design, but a revolution in its material. It was the complete and total embrace of plastic. The rise of the plastics industry in the post-war era was a perfect match for the burgeoning roll-on market. New polymers like polypropylene and high-density polyethylene offered a set of properties that seemed tailor-made for the dispenser. These materials were lightweight, unbreakable, and chemically inert, meaning they would not react with the products they contained. Most importantly, they could be manufactured with incredible precision and at a very low cost through a process called injection molding. This technology was the key that unlocked the roll-on's global potential. Injection molding allowed for the creation of both the ball and the fitment with a single automated process. Molten plastic was forced under high pressure into a precisely machined steel mold. In a matter of seconds, the plastic would cool and solidify, and the mold would open to eject a perfect finished part. This meant that the critical microscopic tolerances required for the fitment could be replicated millions of times with absolute consistency. The expensive, delicate glass ball was replaced by a lightweight, durable, and perfectly spherical plastic one. The heavy glass bottle was replaced by a light, squeezable plastic one. This all-plastic construction had a cascading effect of benefits. It dramatically lowered the cost of manufacturing, transforming the roll-on from a premium, high-end product into an affordable, everyday item accessible to everyone. The lighter weight of the plastic also significantly reduced the cost of shipping and transportation, and the unbreakability of plastic made the product safer and more portable. The roll-on could now be tossed into a gym bag or a suitcase without a second thought. This plastic revolution also unleashed a wave of design innovation. Freed from the constraints of glass manufacturing, bottles could be molded into a huge variety of ergonomic and eye-catching shapes. And the technology was no longer limited to deodorant. The low cost and versatility of the all-plastic roll-on made it the ideal dispenser for a vast array of other products. Roll-on glue sticks with their wide, flat balls became a staple of schools and offices. The medical field adopted the roll-on for applying topical analgesics and insect repellents. The cosmetics industry used it for lip glosses, eye serums, and perfumes. The quiet, humble sphere, now rendered in lightweight, inexpensive, and versatile plastic, had broken free from its origins and was poised to become one of the most ubiquitous yet unnoticed pieces of technology in the world. Our journey, which began with the sticky, frustrating mess of a cream in a jar, ends here, in the quiet, effortless, and invisible presence of a perfect sphere. It ends with an object so common, so deeply integrated into the fabric of our daily lives, that we have become completely blind to its simple genius. The roll-on dispenser is the ultimate example of a successful technology. It has solved a problem so completely that we have forgotten the problem ever existed. To use a roll-on today is to participate in a silent legacy of innovation. It is to hold in your hand the culmination of a frustrated editor's thoughts on ink, an observant woman's brilliant epiphany, a team